Hi guys, welcome to this set of videos. These videos are going to go along with the section or the notes that are out of Chapter 2, Section 7. Now, like I said with Section 6, both Chapter 2, Section 6 and Chapter 2, Section 7 deal a lot with graphing. And what we're doing in these two sections is, like I said, we're laying the foundation on which we're going to build graphing in later chapters here in Algebra 2. So please make sure that you are very comfortable with what I go over here, both in Section 6 and in this section right now. You're going to hear me use this word, transformations, pretty much every chapter from here to the end of Algebra 2. When it comes to graphing functions that will come in later chapters, we're still going to use this idea of transformation. So you'll notice that this one doesn't have any specific objectives or learning targets. It's because everything I'm going to say in this section, you need to know. All right? You need to know how to do all of this. When it comes to transformations, it's incredibly important. We're going to start here. It doesn't go away. We're going to use it for the rest of the year. Let's go ahead and jump right into it. What they're going to introduce you to here in this section are four graphs that are very, very common in algebra. So let's go ahead and take a look at these. So what I'm going to show you here are going to be four common graphs. These are going to be the following. Are the simplest representations of four of the most common graphs in algebra. The first one is the constant function. This one is really, really easy. You can probably see it written there in the definition, but this is just simply f of, oh, hang on, that's my highlighter, I apologize. This is just simply f of x is equal to a, where a is any number. Pick your favorite number, right? This is the constant function. So if f of x is equal to a -2, well then that means that y is equal to a -2, and you'd have -1, -2, and you have a straight line going across -2. If x was equal to pi, 3.14 repeating, right? Well, you'd have to round because you need to, right? You can't graph an irrational number. But if you went 3.14, right, I would go 1, 2, 3.14, right? And I just have a constant line going across at 3.14, right? Constant function, whatever a is equal to, you have a straight line crossing y value, horizontal line at that value of a. The next one is the identity function. This guy right here. The identity function, you can see in the definition there for you, I'll write it over here, is f of x is equal to x. What this one is going to be is the identity function, right? And it's just going to be a horizontal line, I apologize. It's going to be a line with a positive slope. There we go. A line with a positive slope that divides the first and third quadrant in half, right? And here's the reason why. If x is equal to 1, well, then y is equal to 1. So 1, 1. If x is equal to 2, well then y is equal to 2. So 2, 2. X is 3, y is equal to 3, right? And so on, right? So you get this positive line dividing the first quadrant. What if I did negative numbers? Well, if x is equal to -1, y is a -1, so -1, -1. Same thing for -2. It'd be -2, -2, -3, -3. And that line just extends in both directions, dividing the first and third quadrant right in half. All right, the next one is going to be the absolute value function. Now, you should remember this from Section 6. We looked at the absolute value function, so you're already familiar with the fact that it is a v centered at the origin. A v centered at the origin. And we looked the last time, this is going to be f of x is equal to, we use the absolute value signs of x, absolute value of x. So there is your parent function for the absolute value. And then the one that we're adding here that we haven't looked at yet, but we'll look at here in this section is going to be this quadratic. Oh, sorry, that is not my highlighter. Hold up. There we go, highlighter. It's going to be this guy right here, the quadratic function. And again, this one, you can read it here in the definition, but this one is going to be y equals, y squared. Hold up. I'm struggling today. Here we go. Y equals x squared. There we go. There's your quadratic function. Once again, you know that quadratics, anytime you have an x squared, it's going to look, we call it a parabola, right? It's kind of this U-shaped graph. We call it a parabola. Could open up, parabola opening up like we've got here. Could be a parabola opening down, right? But anytime you just have y equals x squared, it'll always be a parabola opening up, centered right here at the origin. All right, that takes care of the 4 basic functions. Please make sure you know these. You do need to know both their equations and what they look like. All right, both their equations and what they look like. So make sure you take some time, read through this page, convert short-term memory to long-term memory so that you know what these graphs look like. We're going to use them all through this section and the rest of the year. Head on over to the next page and we'll get some practice with what kinds of problems I'll ask you to do based on these 4 graphs. I'll meet you over there.